Hey guys.
Hey gang,
How are ya?
we are coming at you live. Actually, it's not live for you,
No.
but we are
It's
coming
for
at you doing something special called Flipping the Classroom.
Okay. I am Whitworth.
I'm Richardson.
So together we are doing something called
Witterson. It was good again.
It was good.
This is
really
actually
good.
time two that we've tried
I know
this,
the
but
first one, not so good.
not so good.
Okay.
Anyway, so what we're going to do is we're going to teach you the easy stuff at home. Then you're going to come to school and do the hard stuff at school. So we're going to work our way into that. Let's get started anyway. So you guys should have out your 1.1 variables and expression notes. And our goal today is to write algebraic expressions.
There you go. Which is one of our first terms. First of all, we talk about quantity. It's anything that can be measured or counted, which is pretty much everything but the air. Okay, you can't count that. Okay, we're talking about variables here, and then she just said algebraic expression. Okay, go for it.
All right, so we've got algebraic expressions which are going to contain a variable. A variable, as you remember from 5th grade, 6th grade, 7th grade, is anything that varies in an equation. It's usually represented by a letter. A, B, C, D. Most of the time we see X or N, etc. Pick whichever one you want, probably not O or T because they look like plus and zero.
There you go.
All right, we've also got numerical expressions. It's an expression that is going to involve numbers
Okay.
and operation symbols. Add, subtract, multiply, divide, plus, minus, times, divide. I already said it twice.
Yeah.
Anyway, so numerical has numbers. Algebraic has numbers and letters.
Got it.
All right.
Here's your chart that has everything listed for you. Plus sign, I know you guys can read. It's all right here. Subtraction and the words. Multiplication, that is where we have a few new ones.
Little tips for you.
Okay. I don't know why it's not there, but it should be a dot right there. Okay.
Your chart has it.
Yeah. And then division.
All right, so whenever I see any of these words in a word expression, I know that I can translate it into one of these symbols. Now, one thing that's really important, get rid of the X as times. We can't do it anymore. It's not good enough.
Right. Sounds good.
We use that dot. All right. First example, writing expressions with addition and subtraction. So clearly we're going to use minus and plus here. So let's look. What is an algebraic expression? Again, algebraic meaning it has a variable in it for each word phrase. Number A, 25 more than a number n. So I see more than. Two things are happening here. One, more than from my chart means plus. So I'm adding something. The other thing that I'm going to let you in on a little secret here, anything that comes before that more than goes at the end.
Right.
So this is going to be something plus 25. What am I adding to 25? A number n. So n plus 25.
And check it out. N plus 25.
Boom.
Got it.
All right, so same example, probably going to be minus.
Because it says less than.
It says less than. 74 less than a number n. So I know that that 74 is going to go at the end. Minus 74 from n. Awesome.
Okay, and if you mix those up, guys, then you're going to get a different answer with that subtraction.
Right, because I can't do subtraction in any order I want.
Okay.
All right. All right, number 2, writing expressions with multiplication and division.
And it says algebraic expression, meaning we're going to use letters, a variable.
First one, 5 times a number n. Times. Wow, tough. Multiply. Problem.
Okay, what's the problem?
Well, I know that we're in 8th grade now and we have to be pretty fancy.
We do.
If I want to write 5 times n,
okay,
I feel like that's not going to look very fancy.
Well, when I just heard you say that, I can literally write 5 times n, correct?
And I feel like that should be the right answer, but it's...
I mean, it was right back in the day.
You know,
but
it's like
we're here today, so we need to...
Right.
Yeah.
We're going to fancy it up.
Yeah.
So 5 times n, we can't use the times sign.
Okay.
I don't want to use the dot because it's like extra steps. It's right.
Yep.
It's not right enough.
That 5 is not right.
No, that 5 is not right.
Nope.
We could also do the parentheses, but again, this is a lot of, it's not working for me. Anytime we have 5 times n, it really all means the same thing, and it's 5n. You guys should remember that from 7th grade. I mean, it's like, hello, 5n.
They're like, dudes, I got this.
Yeah, fast forward. All right, now let's keep going.
Okay.
B, The quantity, no, that says quotient.
Mhm.
I'm having, good thing I teach
We
math.
teach math, right?
Not
A
reading.
couple letters at a time.
Oh, whoa. The
Woo!
again,
Quotient.
the
The
quotient
quotient.
of a number in and 7. Okay, here's the problem. I know I'm dividing. I don't know what order to do it in.
Well, if you're super confused on if you're dividing even, refer to your handy dandy chart.
because it says quotient
It says
under
quotient
the
on
division
it.
sign.
Okay?
So but I wasn't confused about that. I was confused
Well,
about
you
the
had jumped
order.
it. I know. She
Okay.
jumped a little bit.
So the order, how do I know which order to do?
Well, I see in and 7, so I'm just going by, I'm not using one of the more than or less than, so I'm just going to read it from left to right.
Okay.
So I have in and 7, but I know it's quotient. So I
In.
can say in divided by 7.
Mm,
I could,
could.
okay? But now that we're fancy, as you have said,
Mhm.
I will do in over 7.
I love it.
Okay.
It looks amazing.
Okay. Oh,
oops.
I clicked it. Here we go, guys.
We got it right. Good thing we made this.
I know.
All right. All right. Oh, man.
Bottom of your page.
Bottom of your page. Remember to turn the page after A.
Got it.
Number 3, what is an algebraic expression for each word phrase? Guys, this time we're going to use 2 operations. We're going to add and times. We're going to, multiply. We may subtract and divide. We're going to do 2 things. We're going to look for lots of keywords. A says for more than.
Okay, so I'm going to underline that keyword.
First of all, it tells me that 4 is going to go at the end.
Okay,
So it's going to be plus 4 at the end.
so I can do this here.
Twice a number x. 4 more than twice a number x. Well,
Okay,
twice means,
well, I can put parentheses around that right now because I don't know what you're doing. So you could highlight it. You can do a different color,
there's
shade,
squiggle,
whatever.
underline, or something
Yeah,
like that.
something.
But twice a number x is going to mean, well, 2 times x. We already know that we can't write 2 and then the times sign, so we're going to write 2x.
Okay,
So that's going to go right before that plus 4.
we know that
2x.
4 is added to that.
Now,
Book's wrong.
Book's wrong, guys.
Okay,
Book's always
I
wrong.
know. Believe us.
Don't do that. You want to do what's over there.
Okay,
Witterson got it right.
boom. We're so good.
All right.
Okay, next.
Turn your page for part B. B, 7 less than the quotient of 8 and a number x. Lots of words. All right,
Sure
so I
is.
know 7 less than means I'm subtracting 7 at the end of the problem.
So guys, don't get overwhelmed by this. Just break it down right away. So 7 less
Break it
than. Wicka, wicka. Okay,
All right, then the quotient, not quantity because I kept
Nope,
mixing it up.
I know.
Quotient means
Division.
divide
Mhm.
of 8 and a number x. Read it from left to right. 8 divided by x.
so what goes on top?
8
Over.
x.
Got it.
Man, we're good.
We are good. That 8's not.
No, that struggling.
Okay.
All right, number C. I said number. Move on.
Hold on.
The product of 9 and the sum of a number x and 2. Okay,
So again, guys, just break it down.
break it down. Oh.
That's still a move. I bet it's still a move.
Yeah, if not, you're going to bring it back.
I am.
All right.
Witterson, you're my partner.
I know. Well, I was doing something with my legs. You guys couldn't even see it.
It's embarrassing.
Product. Okay, product means times, right? So the product of 9 and then a whole bunch of other stuff. So I know I'm doing 9 times something. Good grief.
Gonna text no cell phones in class.
I know.
guys.
Don't do
Okay.
it. All right, so the product of 9 and the sum of a number x and 2. So I know the green stuff is all one thing. So let's talk about that first. The sum of a number x and 2. So that means I'm adding x plus 2, right?
Yep.
But I want 9 to be multiplied by all of that whole thing and not just by the x. So I wouldn't just put a 9. So put that 9 there. Let's put the 9 there. 'Cause
Okay.
I know I'm multiplying. If I just have that 9 there, it looks like I'm just multiplying 9 by x. But I want to multiply it by all of the x plus 2. So I'm going to group x plus 2 together with my grouping symbols.
So you're gonna marry it together.
Marry it together.
Mhm.
Put it in a little package, parentheses. So 9 times the sum of x plus 2. Fancy. We got it.
Guys, we like fancy, okay?
We're so fancy.
As Iggy would say.
You already know. You want to sing it?
Maybe not yet.
Okay, not yet.
We'll hold on to it.
All right. Number 4, using words for an expression. So this time we're going backwards. We're going to make the expression into word phrase, right? What word phrase can you use to represent the algebraic expression for x? Well, 4x means 4 times x. But we said 4 times x is not, it's not
8th grade level.
right.
Yep.
On another level here,
Right.
guys. So instead of saying times, I could use probably product.
Yep.
So this is the product of what two things? What two things were you doing?
Well, I have 4
And
x.
so it's the product of 4 and
4
x. Uncover it.
Or again, you could use 4 multiplied by.
You could.
Just look at your chart.
Mm-hmm.
Okay? Product of 4 and a number x.
Write it down. Next. All right. Number 5, last thing, then we're done.
We're good at
Writing a rule to describe a pattern. So we're going to look at this table, analyze what pattern is happening. Here's the situation. The table shows how the cost of renting a scooter depends on how long the scooter is rented. Well, duh, you're going to pay more the longer you rent,
Right,
okay?
right.
So what is the rule for the total cost? And then give the rule in words and as an algebraic expression. So we're going to write it out in words, and then we're going to give that little expression we've been practicing.
Perfect.
All right, so let's look at how this table is increasing. Let's look for the pattern.
Okay? So I'm looking at it 1 hour at $17.50, 2 hours, $25.
Probably need to subtract those to see the difference
Yeah.
between them.
Yeah, so I would do $25 minus $17.50 to find the difference.
Mm-hmm.
So Richardson has her calculator out,
Mm-hmm.
and we're finding that is a difference of
$7.50.
$7.50.
Okay, so I know that for every hour, it costs me $7.50.
Right.
So, but what about at 0 hours? Because this table starts at 1.
Well, I just went down and I said plus $7.50 each time.
Mm-hmm.
Okay?
So going up the table or where it to
Backwards.
0 backwards,
Mm-hmm.
be
So imagine there was a 0 there, so I would take $17.50
minus
minus $7.50.
and that's going to give me, well, that's 10. So I know that there's an initial cost of $10 just to like get
So startup fee.
Yeah, get the
Yeah.
bike or whatever. So
Scooter.
anyway.
On you.
All right, so it's $10 plus, right?
Mhm.
Because it starts at $10, and then I'm adding
How much an hour?
how much an hour? I'm adding $7.50 each hour, so that's $7.50 times hours, or $7.50 each,
Got it.
plus that initial fee. Okay, now we said that out in words, so we would say 10 plus $7.50 per hour.
Right.
And then there's our algebraic expression, right?
Yep.
I love it.
Ah, what am I doing? There you go.
Oh my gosh, we did awesome. We did amazing. Okay, there's an extra example on here. It's not on your paper, guys, so you don't even have to do it.
Yeah.
The last thing we want you to do, though, is we want you to go to the summary, which is at the bottom of your next page,
Uh-huh.
which is on our next slide.
I don't know. Oh, yeah. Okay.
Here's what you're going to do. Tomorrow when you come to class, actually, I'm just kidding because we're in class right now probably.
Right.
We're going to take time to discuss this as
A table.
table.
Yeah.
Okay,
With
so,
your partners.
or your table partners.
Yeah.
All of them.
Sure, all of them. Yeah.
Yeah. So how is an algebraic expression like a numerical expression, and how are they different? Food for thought, friends.
So think about it on your own. Tomorrow you're going to talk about it with your partners.
Boom. Back at you in a bit.
And you're welcome.
See ya. Am I doing it?
Yeah.
Okay. All right. Adios.
Okay, bye.